In this last video, we're going to go ahead and take an example of a function that's had different operations applied to it, and we're going to have to identify the certain types of transformations. So hopefully you've read through the guide that talks about what type of transformations are possible, and then we'll use those to kind of help us work through them. So here is our original function. Our original function is f of x equals x squared. And what we're doing is we're doing 4 transformations to turn it into g of x equals -1/2 times x plus 1 squared minus 5. Now, one thing that I do like to do is graph this, and we can easily do that on GeoGebra. I'm going to go ahead and grab my GeoGebra tool here. And just in the input bar below, I'm going to start by writing f of x equals x squared, so I can see that original function. That original quadratic is in green, and then I'm going to type in g of x equals -1/2 times x plus 1 squared minus 5. And then I'm going to hit enter. And notice it does give it 2 different colors, which is super nice. And I'm going to zoom out a little bit so I can kind of look at the differences here. And notice the green function is the original function, and it looks like I'm doing a couple things here. It looks like I'm flipping it across that x-axis, and it also looks like I'm dragging it down as well. So I'm dragging it down the graph, and maybe a little slightly to the left. If I zoom in, it looks like I'm dragging it to the left as well. So graphing it is a great tool to kind of see where we're headed and make sure that we're doing this correctly. So I'm going to go ahead and take a snapshot of this. So edit graphics view to clipboard. That's going to copy that picture for me. And then I'm going to come back here and just paste it onto my, oh, that is really large and we do not need it that big. So let me scale it down a bit for you, just so that we can see the 2 different functions. And then, so here are 2 functions. The green one, again, is your original parent function, x squared. And then the red one is your transformations. If you look again, it almost looks like it's stretched a little bit horizontally. So going this direction, it looks stretched as well. But let's try and identify. So there's a couple things going on here. So I'm going to circle these ideas. So it looks like there's a negative going on here. It also looks like there's a 1/2. Be careful because that negative is separate from that number that's being multiplied out front. We'll discuss that a little bit more in a second. It also looks like we're adding 1 inside those parentheses. And then we're also, we get green here, we're also subtracting 5 off at the end. So let's just start with this subtract 5. Now, we're subtracting 5 units, and we're doing it outside of those parentheses. So the parentheses, let me emphasize them here. The parentheses are here, okay, indicating whatever's inside those parentheses is inside that parent function of x squared, okay? So -5 would be outside those parentheses, so outside. And when you have a number being subtracted or added outside of your function, that's going to indicate you're either going up or down. Now, since we're going down, I'm sorry, since we're subtracting, that means we're going down. And if we look at our graph, it's reassuring us because that original green function has shifted down 5 units, right? Down 5 units here. So shift down 5 units. That's our first transformation, okay, that we've come up with. Now let's go inside those parentheses. So now we're inside the function. Now if you're inside the function and you're either adding or subtracting, those are indicating that you're either shifting the graph to the right or to the left. Now these are easily confused, so let's talk about this a little bit more. So we're adding 1 inside, so it's inside those parentheses, so it's inside the function. Now, when you're adding inside, it's common to want to feel like you should move to the right because you think positive to the right, negative to the left, but it's actually flip-flopped. So when you're adding inside, you're actually going to move to the left. So we're going to shift to the left 1 unit. And that's just because we're adding one more possibility to our problem. So you can see here that it did shift to the left here by 1 unit as well. So it kind of shifted. That one's harder to see, but it's in there. The graph just helps us to reassure ourselves, right? Okay, so it looks like we're to the outside of those parentheses again. So we're outside, and we're multiplying by 1/2. So our third transformation, we're multiplying by 1/2 outside of our function. Now sometimes this one, even for me, it's hard to remember. Okay, multiplying outside. So we can grab either your notes. So if you want to just grab your notes, you can see multiplying by a number is our stretching and compressing area. So we're multiplying outside the function, so it's not inside. So it would be either stretching or compressing vertically. So think of silly putty here. You're either stretching the graph up or you're compressing it. It all depends if you're multiplying by a number that's greater than 1, so 2, 3, 4, or a number that's less than 1 but greater than 0. So 1/2, 1/3, 1/4, 1/5, any number like that. So we are multiplying by 1/2. So that indicates, can't find my stuff anymore. Okay, that indicates that it's a number less than 1. Since it's outside, that's going to be compressing vertically by the amount on the bottom of your fraction. So we're going to be compressing vertically by 2. So compressing vertically, compress vertically by 2. It's easy to get those confused, so just go back to your notes and match up with which one is which. So basically, vertically it's straight up and down, right? So we're taking that graph and we're going to compress. We're going to push it together by 2. So we're squishing it, okay? But what happens when you squish that silly putty? It goes out the sides, right? It's got to go somewhere, so it's going out the sides. So it may get shorter, but it gets a little fatter. And you can notice here that our graph, we can't really tell that it's getting shorter. The quadratic doesn't do a nice job of demonstrating that. But if you notice, it does get a little fatter. Okay, it goes in the opposite direction. So it is compressing vertically. One last thing, and this is probably one of my favorite transformations. And the last one is we're multiplying by that negative. So we're multiplying by a negative value. Now again, we're multiplying outside of those parentheses, meaning out front, so multiplying outside. And this is, when you multiply by a negative, this is where the reflections come across, or where you're reflecting it across an axis. Okay, so when we're multiplying by a negative outside, that's a reflection across the x-axis. Okay, so here's our x-axis. It's just taking that function and flipping it upside down. Boop, boop. If we had multiplied by a negative inside those parentheses, that would indicate we would have taken the graph and just flipped it across the y-axis. So here's the y-axis. We would have just flipped it across that way. And again, you can look at this graph and notice we did take the function and flip it. I can't really bend my arm that way, but we flipped it across, right? Now it's upside down. across that x-axis. It's upside down now. Okay, so that was our transformation example. Give it a try on your homework. I believe there are 3 transformations. Make sure you're identifying each one of those. Okay? It can be a little tricky at first, but always go back to those notes and reassure yourself. And if you have questions, feel free to reach out to me, okay?